Hi guys, welcome to lesson 8.6, factoring ax squared plus bx plus c. So our objective for today is just that I can factor trinomials of the form ax squared plus bx plus c. And the same essential understanding basically as yesterday, you can write some trinomials of the form ax squared plus bx plus c as the product of two binomials. So you'll notice the main difference of this lesson is that we are going to have a coefficient in front of our x squared term that is not 1, which it was in the previous lesson. So we have some new strategies on how to solve these kind of factoring problems. The first one that I have is 3x squared plus 7x plus 2. Now the first step to dealing with these is we need to find the product of our a term and our c term. So 3 times 2 is 6, and that is the product that we are looking for. All right, our sum still comes from our middle term, which is 7. All right, so we're looking for factors of 6 that add up to 7. Well, we've got 2 and 3, that adds up to 5. We have 1 and 6, that adds up to 7. So our two factors are going to be 1 and 6. But now we've got a slightly more complex thing that we need to do. The method I'm teaching you is called box method, and it's using these boxes that I have provided for you so generously. And what we're going to do is we are going to plug in some information. Now, two of the pieces of information are always going to be the same. The top left box is always your a term. So it's going to be 3x squared in this case. Your bottom right box is always your c term. So for this one it is 2. Okay. And now you take the two factors that you found here and you put them in the other two boxes. It does not matter which one you put where. So now what we need to do is we need to actually find common factors in our rows and in our columns. So this is why, if you remember back to when we first started multiplying binomials in lesson 8.3, I showed you using the table method. So now we have the table, we just need to move outside and find what's on our outer edges that we're multiplying. So we're going to look and see what are my common factors from this row. Well, I have a 6x and a 2, so my common factor here is a 2. In this row, I have a common factor. We've got 3x squared and we have 1x. Well, the only common factor there is an x. Okay. Going vertically, 6x and 3x squared, my common factor there is 3x. And going vertically here, 2 and x, my common factor is a 1. So if you'll think about this, 3x times x gives us 3x squared. 1 times x gives us 1x. 3x times 2 gives us 6x. 1 times 2 gives us 2. So our factored form of this equation, or this expression, is 3x plus 1 times x plus 2. Okay. And if you wanted to, you could FOIL it and double check. So let's do that. 3x times x is 3x squared. 3x times 2 is plus 6x. 1 times x is x, and 1 times 2 is 2. 3x squared plus 7x plus 2. That is identical to what we started with. So our answer, we know, is going to be correct. All right, so problem B, 6x squared plus 13x plus 5. So we are looking for our a term and our c term. We multiply them. 6 times 5 is 30, which is right there. So we want factors of 30 that add up to a sum of 13. So my factors of 30, we could start with 1 and 30. That gives us 31, not what we want. 2 and 15, that gives us a sum of 17, not what we want. 3 and 10, there we go, there's our 30. So now we plug in our information. Remember, top left box is our a term, 6x squared. Bottom right box is our 5. Those two come from the equation. And now we use our two factors that we found, 3x and 10x. It doesn't matter which one you put where, because when you do your factoring, you'll pull out your common factors. They'll just mirror. You'll have this side here and this side here. If you put 10x up top and 3x down below, they would just flip places. You would still get the exact same factors. All right, so let's take a look at what our factors are. Our common factors in the bottom row, 10x and 5, well, they both have a 5. 3x and 6x squared, both of those terms have a 3 and an x. Going vertically, 6x squared and 10x, both of those terms have a 2 and an x. And 5 and 3x, both of those terms have a 1. So your factored form is going to be 2x plus 1, 3x plus 5. Okay. Letter C, I want you guys to try on your own. So the first thing that you need to do is 2 times 21, which gives us our 42, the answer to life and everything. Now, we need to figure out what are my factors of 42 that add up to a negative 17. Okay, so we know we need one positive, one negative number here, and my negative needs to be the greater of the two. So we have 1 and negative 42. That's going to give us negative 41, pretty far away. 2 and negative 21 gives us negative 19, negative 20, negative 19, getting closer. And let's try 3 and negative 14, that's a factor. That gives us our negative 11. What if we did negative 3 and negative 14? That'll give us negative 17. Right, because this has to be positive, so they both should have been negative all along. All right, so we have our two factors. So we have our negative 3x, negative 14x. That's where we got those. Now let's just plug in our information from our equation. We have 2b, sorry, these are b's. Forget that I changed variables, 2b squared. And we have a positive 21. So in my first row, we've got 21 and negative 14b, so a common factor. Anytime we have a negative sign here, we're just automatically going to bring that out. And same here. When we have a negative sign in this box, we automatically bring it out. All right, so we have a negative 14 and a positive 21. Our common factor there is a 7, so negative 7. Between a 2b squared and negative 3b, our common factor there is b. If we work vertically, common factor between 2b squared and negative 14b is a 2b. And vertically here, we're going to have a negative 3. So our two terms are 2b minus 3 and b minus 7. Okay. All right. Now, problem number 2, factoring when AC is negative. So our product is going to be negative. We have 2 times negative 3. That's going to give us negative 6, which is right here. So we need to know that our negative value has to be the greater of the two digits. So we've got a 1 and a negative 6. That sum gives us negative 5, not what we're going for. 2 and negative 3, that's going to give us a sum of negative 1, which is what we wanted. So we plug those in. We have 2x, negative 3x. Take our information from our equation, 2x squared, negative 3. And now we need to factor. Common factors here. Again, you have a negative sign in this box, so we bring that negative outside. We've got a negative 3x, negative 3, so our common factor is negative 3. Second, or top row, 2x and 2x squared, our common factor is a 2x. First column, we have 2x squared and negative 3x, so our common factor there is just an x. And 2x and negative 3, our common factor is just a 1. So our equation, or our expression, is 2x minus 3 and x minus 1. Okay. Next up, letter B. 5 times negative 18. That gives us our factors of negative 90. And now we need to figure out what are they. That give us a sum of negative 1. So I'm going to skip the 190 because, come on, we know that's not right. So I know it needs to be a negative, so we've got 3 and negative 30. That's going to be negative 27. Not quite there. Well, what are our other factors of 90? Oh, well, I mean, the most obvious one would be 9 and negative 10. 9 plus negative 10 gives us a sum of negative 1. So we have 9x minus 10x. We put our first term in, 5x squared. We put our last term in, negative 18. So we see we have a negative sign in this box, so we automatically bring the negative out there. Factors that are in common between negative 10x and negative 18 is going to be a negative 2. Factors in common of 5x squared and 9x is just going to be an x. Common factors of 5x squared and negative 10x is 5x. And common factors of 9x and negative 18 is 9. So you have 5x plus 9 and x minus 2. Okay. Next up, letter C. Again, I want you guys to try this one out on your own, and we'll go over it. So we have 10 times negative 14. That gives us our product that we're trying to get of negative 140. And let's think of our factors. So we've got negative 14 and positive 10. That'll give us a negative 4. All right, so we need to flip that around. We need a positive number to be our greater of our 2. So what if we tried, we're kind of going a little further, negative 4 and 35. That's going to give us a sum of 31. So plug in our table, 10y squared minus 4y plus 35y and minus 14. So for this one, we've got our negative signs right here, so our negative comes above that box. And let's start looking for common factors. So negative 14 and negative 4, that has a common factor of 2. 35y, 10y squared, well, it's got a y, and 35 and 10 are both multiples of 5, so we have 5y. First row, 10y squared, negative 4y. Both of those are factors with 2. So we have a 2 and a y, because y squared and y. And then we've got 35y and negative 14, so common factor there is a 7. So 2y plus 7, 5y minus 2. Okay? All right. Next page in the notes, problem number 3. applying trinomial factoring. So the area of a rectangle is 8x squared plus 22x plus 15. What are the possible dimensions of this rectangle using factoring? Okay. So 8 times 15 is going to give us our 120. And let's start looking for factors. Well, we could use 8 and 15 as a starting point. 8 and 15, that's going to give us a sum of 23. Not quite what we want. We're close, though. Well, what are some other factors? Well, let's go with maybe 10. So we've got a 10 and a 12. 10 plus 12 is 22. That's what we're going for. So we plug in our information. So we have the first term, 8x squared. One of the factors we came up with, the other factor we came up with, and our last term, which is 15. Vertical, 15, 10x, common factor is 5. Vertical here, 8x squared, 12x, common factor is 4x. First row, 8x squared, 10x, common factor is a 2x. And 12x and 15, our common factor is a 3. So we have 2x plus 3, 4x plus 5. All right. Problem B, I want you guys to try on your own. The area of a rectangle is 4x squared minus 7x minus 15. The width of the rectangle is x minus 3. What is the length of the rectangle? So, like what I said yesterday when we knew one of the sides, that means we know one of our factors already. So we know we've got a -3 for a factor. Well, what is another number that multiplies by -3 to give us 60? And that is going to be 20. That adds up to, well, that doesn't give us what we want. That gives us a sum of 17. So what are some other factors that we can come up with? Oh, that's right, because this x minus 3 doesn't help us with these factors because it doesn't go directly into the factored form. That's right. Okay. Anyways, sorry, moving on. It'll be a different sheet for me to show you. -3 and 20 gives us 17. Okay, that's not quite close enough, and we need it to be -2, so our greater value has to be negative. Well, what about 6 and -10? That gives us -4. Okay, we're close. We're getting in the ballpark. How about, well, if it ends in a 0, so we can divide that by 5. So let's do 5 and -12. That gives us a -7. So we plug our information in. 4x squared, -15. We've got a -12x and a 5x. All right, so up here, pull out a negative sign because we have a negative in this box. And common factors of 12x and 15 is 3. Common factors of 4x squared and 5x is just x. Common factors of 4x squared and -12x is 4x. And common factors of 5x and -15 is 5. So your two factors are 4x plus 5 and x minus 3. Now, I promised you a little bit of a cheat on this, and I will deliver. So we know one of our factors is x minus 13. We can just plug in x minus 3. So we have x and -3 here. Now let's say we don't know these two pieces of information. And we don't know anything there yet. Well, what times x is going to give us 4x squared? 4x. What times -3 is going to give us -15? +5. So we didn't even need to go through the step of factoring and getting these two terms that I'm hiding with my thumb and finger, and we could still have solved this equation, expression. All right. Problem 4 is going to present the skill that is forgotten about most often later on in the year, and that is factoring out a monomial first. So the first thing you want to do when you are factoring these problems is to figure out, are there any common terms from my original equation? Now, when we get down into chapter 11 and we're dealing with rational fractions with rational terms, and we've got to figure out what needs to cancel, this is the step that trips people up the most, because you always are forgetting, you're rushing to get into factoring. So the first thing we need to do is look for any common terms. Well, 8x squared, negative 36, and negative 20. There's no variables that can get pulled out, but we do have a constant, and each of these are divisible by 4. So we divide out 4. We are left with 2x squared minus 9x minus 5. So all we did so far is factored out a monomial, and now we figure out what is our product that we're trying to find. So we have 2 times negative 5. So our factors of negative 10, and our sum is negative 9. So factors of negative 10 that add up to negative 9, pretty obvious. Negative 10 and 1 add up to negative 9. So over here, we put in, we're going to ignore the constant that we've pulled out. So we put in 2x squared. We have minus 10, sorry, that'll be minus 10x. We have an x, and we have negative 5. So we have a negative sign in our outside box, so we put a negative there. We can bring out a 5 out of 10x and 5. Vertically, 2x squared and x, we can bring out an x. Horizontally, 2x squared and negative 10, well, we can bring out a 2 and an x. And x and negative 5, we have a 1. So now when you write your completed form, you write 4, because that is one of our terms that we factored out. Then we have our 2x plus 1, and then we have x minus 5. So this one is going to have 3 factors to it. Okay. All right. Moving on to letter B on the next page. We have 30x squared plus 14x minus 8. So for this one, we need to find a common factor we can bring out. These are all even numbers, so we can bring out a 2. So we have 2 times the quantity, 15x squared, plus 7x minus 4. 15 times negative 4 is negative 60, and our sum is going to be 7. So let's start somewhere in the middle. Let's go with a 20 and negative 3. That gives us 17. Close, not what we want. How about a 12 and 5? 12 and negative 5. 12 minus 5 is 7. So we put in our factors. 15x squared, negative 4, so we got those two out of the equation that we had already pulled a common factor out of. Then we've got a 12x and a negative 5x. So we need to factor these terms. So 12x and negative 4, common factor there is a 4. 15x squared and negative 5x, common factor there is 5x. 15x squared and 12x, common factor there, is 3x. Common factor here, negative 5x and negative 4, is going to be a negative 1. All right, so our final factored form is 2 times 5x plus 4 times 3x minus 1. Okay, so with these, if you are not factoring it completely, if you did not bring out that common term at the beginning, you would not have the correct answer. You would still have some factoring to do. Okay. All right, next up, 4x cubed plus 44x squared plus 36x. Well, I can factor out a constant and a variable on this one. So it looks like these are all divisible by 4, and they're all divisible by x. So we have a 4x on the outside. We're left with x squared plus 11x plus 9. Okay, so we're looking for factors of 9 that add up to 11. Well, let's try. We've got 1 and 9. That gives us a sum of 10. We have a 3 and 3. That gives us a sum of 6. Now, you might be asking yourselves, Mr. Boland, have you lost your mind? The answer is no, first of all. Second of all, there is a method to my madness. And remember, back when we looked at our essential understanding, it said you can write some trinomials of the form ax squared plus bx plus c as the product of two binomials. And if you look back into your 8-5 factoring notes, you can see it says you can write some trinomials in the form x squared plus bx plus c as the product of two binomials. So what is that telling you? That means that not everything is going to be factorable. This is a possibility that you're not going to be able to factor something. There are no integer values that we can use that are going to give us a product of 9 and a sum of 11. Now, this equation does have solutions, but they are decimals that we're not going to be able to calculate without a calculator. And that is for us to deal with in Chapter 9. So, this example would be not factorable. Now, just because I told you that something could be not factorable does not mean that every problem that is difficult is not factorable. Okay, you got to look and make sure that you're looking at all of your possible multiples. And in this case, there just isn't one that is going to work. All right, letter D. We have 3y squared minus 3y cubed minus 5y squared plus 2y. There are no constants that I can pull out of this, but I can pull out a y from each of my terms. So we have 3y squared minus 5y plus 2. So our product, 3 times 2, is 6. Our sum is negative 5. So we're looking for, so let's remember, our product is positive, our sum is negative, so that means both of our factors have to be negative numbers. So we have negative 1 and negative 6. That gives us a sum of negative 7. We have a negative 2 and a negative 3. That gives us a sum of negative 5, which is what we wanted. So now we can factor. So we have 3y squared. We have 2. These are coming from our equation. And we've got negative 2y, negative 3y, and now we can factor. So common factors here, bring out the negative sign because it's right there, and we have a negative 2. Common factors here, 3 and y. Common factors in the top row are just y. And common factors in our bottom row is negative 1. So our factored form is going to be y times 3y minus 2 times y minus 1. Okay. That is the end of our notes for today. Make sure you fill in your level of understanding for these problems. 1 being lost, 4 meaning I can teach this lesson. Make sure you write down any questions, and I know you have them, so make sure you write them down. And make sure you come up with your summary of what to do when factoring trinomials where there is an a value that is not 1. So anything other than 1 attached to the x squared term. That's our lesson for tonight. Have a great night.